Hi everybody, welcome back. My name is Becky and today we're going to start on a new math topic. We're going to talk about the properties that you might encounter when you're working on algebra problems. Some of them are going to be helpful in helping you actually do the problem. Some of them are going to be helpful to keep in mind so that you know what you can and cannot do when doing the problem. So today we're going to talk first about the commutative property and then we'll finish up with the associative property. So first, the commutative property. When it comes to the commutative property, there's one thing to keep in mind, and that is that order doesn't matter. And one way you can kind of think about this is that if you think about the word commute, okay, you're going to be thinking about how you go from work to home and home to work. You're changing places. The same thing applies when we talk about commutative property in math, is that order doesn't matter. You can move them around. They're fluid. They travel, okay? The thing to keep in mind, though, is that they only apply to all addition expressions or all multiplication expressions. You can't mix and match them. It's all addition, all multiplication. Okay? So as long as you're dealing with those sorts of expressions, you can move the numbers any way you want, and the order doesn't matter. So think about when you were first learning addition. You learned that 2 plus 3 was 5. And then very shortly after that, you learned that 3 plus 2 was also 5. So you learned that when it came to adding those two numbers together, it didn't matter what the order was. And then the same thing happened later when you learned multiplication. You learned that 4 times 6 was 24, and then maybe a week or two later you learned that 6 times 4 was also 24. So very intuitively you started to understand that when it comes to multiplying those two numbers, order doesn't matter. But what if you have more than two numbers? What if you have a string of 3 numbers, or 4 numbers, or a million numbers? Well, the commutative property still applies. So let's see how this works, okay? We're going to start with addition. And I'm going to have 2 plus 3 plus 5. Okay? So 2 plus 3 equals 5, plus another 5 is going to give us 10. And now I'm going to mix up the numbers. I'm going to start with 3, and then we'll add 5, and then we'll wrap up with 2. Okay? So 3 plus 5 is 8, plus 2, well, that's also 10. And you could do this with any number of problems. Experiment with yourself, while you're driving through to work, when you commute, going to school, okay? Just kind of try different number variations and prove to yourself that, it doesn't matter what order I put the numbers in, when I add them up, they're still going to have the same sum. So this is how it works for addition. Now, how about we look at an example with multiplication? Okay, so now that we saw that with addition, let's go ahead and see the commutative property with multiplication. Okay, so we're going to go with 4 times 6 times 1. So 4 times 6 is 24, which times 1 is still 24. Okay, and again, I'm going to mix up the numbers. So let's go with 6 times 1 times 4. Okay, 6 times 1 is 6, times 4 is 24. So just like with addition, we see that multiplication is also commutative. So one thing I want to point out though is that this works for numbers, but it also works for expressions and variables. So keep in mind that if you have x plus 3 equals, say, 8, you can also say 3 plus x is 8. Okay, so it's not just numbers. This applies to algebraic expressions as long as you keep it all in the addition family or all in the multiplication family. So that's the commutative property. Next up, let's talk about the associative property. So now let's move on to the associative property. Now the associative property has a lot to do with how it sounds. Associate, association, grouping. All right, so what the associative property says that if you're dealing with an addition expression or if you're dealing with a multiplication expression, then the grouping of the numbers doesn't matter. Okay, so this one was a little less intuitive. We didn't have obvious examples from childhood, so let's just jump into an example. So we're going to start with 8 plus 9 plus 10. So 8 plus, sorry, put the grouping on there. 8 plus 9 is 17, plus 10 is 27. Okay? Now we're going to leave the numbers in that order. Okay, we're not touching order on this one. We're just going to change the grouping. So I'm going to have 8 plus, now I'm going to have the new grouping. 9 plus 10. So 9 plus 10 is 19, plus 8 is also 27. Okay? So when it comes to the grouping of numbers within an addition expression, we can see that the grouping doesn't matter, and that complies with the associative property. Now let's see how that works with the multiplication. All right, so now let's see the associative property in work on multiplication. So now we're going to go with a grouping of 2 times 4 times 6. Okay, so 2 times 4 is 8, times 6 is 48. Again, I'm going to leave the order alone, I'm just going to change the grouping. So I'm going to have 2 times 4 times 6. So 4 times 6 is 24, times 2 is also 48. Okay? So there's an example of multiplication. There's another example of multiplication that deals more with expressions that I have seen more frequently in recent months with algebra students, and I just want to address that particular example real quick. So if you run into something where you have 3 times x over 2, okay, keep in mind that the grouping says that we can actually call this 3 over 2 times x, okay? This is simply changing up the grouping. Instead of having 1/2 times x as one grouping and then 3 on the outside, we have 3 times 1/2 as one grouping and the x over here, okay? This is still an application of the associative property, all right? Okay, so last but not least, we're going to do an example. We're going to throw it all together, commutative and associative, mass hysteria. Let's see how that looks. All right, so we're going to wrap up today's discussion of the commutative and associative properties with a big compilation problem, okay? Keep in mind though, we have to either stick all in addition or all multiplication. We can't mix them up. So for simplicity's sake, I'm going to stick with addition, okay? So we're going to have 3 plus 2 plus 6 as a group, okay? And we're going to find out if this is equal to 6 plus 3 as a group plus 2, okay? So it's all addition, but on this side the order is 3, 2, 6, and this one is 6, 3, 2, and our groupings are different. So let's work out each side independently and verify that they're the same, okay? So on this side, 2 plus 6 is 8. Plus 3, that's 11. 6 plus 3 is 9. Plus 2 is also 11. So that's the cool thing about the commutative and associative properties. You can use them simultaneously for whatever the problem calls for. Whether you're adding up a whole big list of numbers, whether you're multiplying a whole big list of numbers, whether you're just trying to move all of the constants to one side of the equal sign so you can figure out what that variable is. Whatever it is you're trying to do with algebra, you can utilize the commutative property, where order doesn't matter, and the associative property, where groupings don't really matter, to help it work out easier and more efficiently for you. Join us next time. We're going to talk about another one of the properties, and we look forward to seeing you then. Thanks!